Hello, and thank you for watching my video. In today's exercise, I will be demonstrating configuring HSRP or Hot Standby Routing Protocol. We will configure HSRP and HSRP priorities, groups, and failover testing. For ease of demonstration, I will be using Cisco's Packet Tracer program, available for download on cisco.com. HSRP, or Hot Standby Router Protocol, is a Cisco proprietary protocol that provides redundancy by adding failover capabilities to default gateways in a network. It allows for an active and standby router to share a virtual IP address so that if the active router fails, the standby router can take over. I have already configured the network for this exercise. I have set up 2 multi-layer switches to be the default gateways for the users on the single LAN. This topology has redundant links, and is using redundant DHCP servers configured on each of the multi-link switches. This is the address I assigned to the VLAN 1 interface. We can see that it is not the same as the default gateway address in the DHCP configuration. The default gateway address is the one we will use to configure HSRP. To configure HSRP, we have to be in the VLAN interface configuration. And the command is standby, the group number, 1 through 255, IP, and the virtual IP we plan to use. We will do this on both multi-layer switches that are acting as our gateway routers. This command is the same on both gateway routers. We see the notification of an HSRP state change and that this router has gone into standby state. With HSRP, one of the routers will be in active mode, meaning all traffic routing through the gateway IP address will be done by it. Standby mode means just that the router is standing by waiting for something to happen to the active router so that it can take over routing duties. We can see the HSRP router state by issuing the show standby command. This shows us the HSRP state, the virtual IP being used as well as the IP of the active router. Let's check the active router. We see the HSRP notifications. Show standby. State is active. Virtual IP. And the standby router's IP address. Let's try some ping tests from one of the LAN PCs. Let's ping the default gateway or virtual IP address. That worked. Now let's run a trace route to the web server IP outside the network. Here we see the physical IP of the active router, then the IP of router 1, and finally the IP of the web server. But what if we want to control which router becomes active or is the standby router? We can do that by setting the standby priority. The higher priority will become active. By default, priorities are set to 100. The command is standby, the group number, followed by priority. Because this router is active, we are going to lower the priority. This active router's priority is now lower than the other router's priority at the default of 100. That's because HSRP will only change state at startup or if active and standby cannot communicate any longer. HSRP active and standby routers communicate with each other using a combination of multicast and unicast messages. However, we can set an HSRP option for preempt. This will send the priority info in the communications and will cause an automatic setting of the active router with the highest priority. You can see that even if we raise the priority on the standby router, the state does not change. Let's add preempt with the command standby group number and preempt. Almost instantly we get the notification that the HSRP state has changed. Now we can see the router with the higher priority is active and that it happened almost instantly once the preempt command was added to the configuration. I'll add preempt to the other router here. We should test connectivity again. Let's ping the gateway. Let's make sure we can still ping through the network by pinging the web server IP. Success. Let's do a trace route and see that the gateway hop IP address has changed. And it does. Now we have changed which routers will be active and which will be in standby with the preempt command. But what if we don't want a router just doing nothing while it's in standby mode? Fortunately, we have an option with HSRP. HSRP groups will allow us to assign different gateway addresses to the LAN devices. This way HSRP Group 1 will be active on MDF switch 02 at gateway address 192.168.10.1. And HSRP Group 2 will be active on MDF switch 01 at gateway address 192.168.10.2. And both will be backups for the groups they are not active on. We can divide the router's workload this way. Let's start by changing the default gateway address in the DHCP pool for devices using HSRP Group 2. A check to make sure the new gateway IP is showing up on the devices. And a ping test to show that we cannot ping it until we set up Group 2 on the multi-layer switches. As expected, there is no connectivity to the web server. Let's configure standby Group 2. IP first. Then set priority. This router will be active, so let's configure 120. There we can see from the notification that Group 2 came up. And we have to set preempt for each individual group. Show standby to see the HSRP groups in our state and standby for Group 1. Active for Group 2. And the new default gateway for Group 2. Now we will configure the other router to be standby for Group 2. Here we see that this router is active on Group 1, no change, but now standby on the new Group 2. Let's ping our new Group 2 gateway IP. Success. Now the web server. There we go. And let's verify the path. It should be through MDF switch 01. Path confirmed. Active on Group 2. Let's do some failover testing. I've added some IP info to the network for easier understanding. To simulate a failure, I'm going to shut down the VLAN 1 interface for Group 2 at 192.168.10.4, This will stop communication between standby and active. Before we fail over, let's verify PC005 is using Group 2 as default gateway. 192.168.10.4 is correct. And we can see the PC002 in Group 1 is using the Group 1 gateway at 192.168.10.5. Let's shut down the VLAN interface. That's odd, the HSRP notification is saying this router became active for Group 1. When we check the standby groups on this router, it takes on active, because it lost communication to the other HSRP router. It can be active but it won't process any traffic because the VLAN interface is down. Now when we check the standby status on the other router, we see that both groups are showing active. So it is processing traffic for both groups' default router IPs. Let's verify. Here we can see the first hop changed. It went from .4 to .5. This validates the failover. Let's recap. We discussed what hot standby router protocol is and how it's used to provide redundancy for LAN gateways. We configured HSRP on the VLAN interface. We determined which router would be active with changing the priority value. Then we configured HSRP groups to allow load balancing of the routers. Next we tested failover. And always, document. Thanks again for watching this video. Please give a like and subscribe so you will be notified when more videos are uploaded.